Yeah, so hello everyone. Before we begin, just a quick disclaimer. Whatever I am sharing today is just for informational purpose and general discussion. This is not a professional or a medical advice. And these are my own views and not my employers or the hosts. So if anything goes wrong, please blame me for that. Okay, so yeah, good evening, everyone. My name is Puneet Kala. I am Senior Software Engineer Android Accessibility at Zalando. And today we are going to talk about intersection of AI and accessibility. We are going to discuss what are the challenges with accessibility and how AI promises to solve them. Let's quickly go through the agenda. So first, we will explore how AI is helping us in digital accessibility. Then we will talk about how assistive technologies have evolved and about the AI's role in that evolution. Then we will understand the power of Google's MediaPipe and how we can use it for accessibility. I have put together a quick demo to show you this. And finally, we will talk about how AI can be built in an accessible way. So let's start with AI in digital accessibility. Let's make sure we are all on the same page about digital accessibility. In simple terms, digital accessibility is all about making sure that everyone can use all the digital content and tools like websites, mobile apps, and software. It's about designing our digital world so it doesn't create barriers, but rather opens up opportunities. So why does it matter to us, or why should we care? In 2003, according to Eurostat, 26.8% people in European Union have some kind of disability. So this is approximately 1 in 4 people in EU, which have long-term health problems limiting their everyday activities. There are roughly 1.3 billion people worldwide, which makes 16% of the population experiencing significant disability. And WHO and UN have acknowledged that these numbers can be an underestimate due to differing data collections, differing definitions, sometimes underreporting, especially in the low-income countries, and especially related to the mental health problems. And third thing, if you are a company who is in Europe, which means if you are a European company or a company who is operating in Europe, there is European Accessibility Act, which mandates the accessibility requirements, and it's already out as of June 28, 2025. So let's start with understanding what AI is already doing to make things accessible. To start, we have smart screen readers. So everyone might have heard about VoiceOver from Apple or TalkBack from Google, and they are now able to describe complex content better than before. They are able to tell you what's inside an unlabeled image. So let's say if we have a back button in the toolbar and we haven't set its content description, TalkBack will be able to recognize that this is a back button and then announce that for you. Apart from that, smart screen readers can now summarize the screen. So TalkBack have recently integrated with Gemini, and you can ask Gemini to summarize the content on the screen for you. Building on that, we have computer vision and image recognition. So Microsoft's Seeing and Google's Lookout are best example for these. So they describe text, objects, people, and currency. They read food labels, and Google's Lookout can help you navigate a room by identifying things like chairs, doors, tables, etc. Then next is something which we probably all use every day, which is voice control and speech to text. An awesome example of this could be Google Gemini or Apple Siri or Amazon Alexa, which basically takes a speech as an input and then perform action or provide you information on basis of that. So this is very empowering for people, especially who have difficulty typing or who prefer speaking. And then we have more and more AI-driven personalization. This is about AI adapting to the user's need. A good example of this could be Google's Gboard or Microsoft's Swift keyboards. These keyboards basically understand how users type, how they communicate, and based on that, they suggest words which or phrases which users can type, and it helps basically complete the sentences. Another good example of this can be Duolingo. If you have used Duolingo, they create personalized practice lessons for you, which are sometimes also called are about strengthening your weak skills. So they recognize what wrong answers you gave in your previous lessons or previous questions, and based on that they create a personalized strengthening lesson for you. So these are just a few examples of how AI is already helping us out there. Now let's understand how these technologies evolved over time. Starting with screen readers. Earlier, the screen readers had very basic text-to-speech capabilities. They used to go through apps accessible tree, and they just used to read out the text or the descriptions provided by the users. The challenge started when the UI started becoming more complex. Like we had swipeable carousels, we had bottom sheets, we had range sliders, and many times we created custom elements which were beyond what was basically offered by, let's say, Android. And when developers created these custom elements, they often forgot to make them accessible, or they didn't focus on accessibility a lot because it was not mainstream earlier. Apart from that, there is a lot of dynamic content. So this could be constantly updating product lists, this could be festive offers, sales, then constantly refreshing home pages. And making them accessible or having an accessible experience with changing content was very difficult. And then there was a need of context awareness. So lot of apps have two types of pages. There is a listing page and then there is a details page. So listing page generally has the list of, let's say, products you have with an image of the product and the text. And the details page have much more images, much more description about that product. We can see such an example in Google Play Store, where they just have the icon and the app name and maybe rating as an information, and when you go inside there are a lot of other things. It was tough for screen readers to identify these differences in the context. So what did it mean? It meant that the old ways were not enough and we needed smart solutions. So how did screen readers solve this? So out of the examples which I have mentioned here, some of them are ongoing researches, some of them are already available for us to use. So first example could be contextual comprehension. Now with AI, it's possible for screen readers to understand the context of what is being said or what is on the screen, and on basis of that explain or announce it for the user. Then we have adaptive reading. So for screen readers, there could be different, there is speaking speed or the pitch of what is being spoken, and this is something which is now which can be adjusted on basis of how users understand that. Then we have dynamic restructuring. This is an ongoing research, and what this does is it restructures the content without changing the look of your app to make it more accessible. So it has a lot of potential, and this research was recently published in 2025. Apart from that, there are AI generated summaries, so like summarizing the screen or article summaries. Then let's talk about evolution of navigation. So earlier people were using white canes or guide dogs or ETAs, which are electronic travel aids for navigating the world. Electronic travel aids are devices which use ultrasonic signals to detect objects, and then they inform the user through sounds and vibrations. Apart from that, if people had to read something, there were large prints available for them. There were magnifiers available for them. So we might have seen someone in our family using a magnifier to read newspapers. And there were braille books in braille. Now the challenges here was that you need to know braille to be able to understand the book, and if you don't know braille, then that could be a challenge for understanding the book. So there was a need for specialized education. Now what all these did was that this increased, or this required human assistance for lot of things for people to do their day-to-day activities. Now how was this solved? Again, coming back to Microsoft Seeing and Google's Lookout, so they basically make smartphones as intelligent eyes. They are able to identify objects in real time. Like for example, if you are walking on a street, it will be, and there is a door in front of you when you turn somewhere. So Google's Lookout will be able to tell you that there is a door in front of you. So this reduces reliance, it enhances independence and safety of the people. Then the next thing is personalization. So before AI came in, the personalization was not truly personalization. Either the content was either for a particular group of people, or even if a personalization could be done, it required a lot of manual adjustment, specialized educators, making it non-scalable and labor intensive. A very good example of this can be, let's say, if there is a math class and there are 50 students in it, and they want a personalized plan for them based on their experience. Now, without AI, what a teacher would have to do is they'll have to go through the score sheets of people and then find what they are strong in, what they are weak in, and then create a personalized plan for every different student. So this is going to consume lot of time for them to be able to do that. So how AI solved it? AI made it scalable and real time. We already discussed the example of how Duolingo makes personalized lessons for millions of people. Then there is predictive text, which we talked about, and this is another example of personalization, and this is often real time. Then there are apps where if you visit certain products or certain products, based on what the products which you have visited, the recommended products change, or the suggested products change. And then the next thing is adapting content or learning experiences. So an example of this could be, let's say I have to understand a very complex scientific theory. AI is able to explain that to me in an understandable language. Or if, let's say, I have a complex, I have an app which gives me math problem, it will see what all I have learned, what is my learning capacity, and give me a problem on basis of that. So what this does is this reduces 41% of the cognitive load from and helps learning better, helps grasping content better. So let's talk about power of Google's MediaPipe and how we can use to make the experience more accessible. So let's understand what is MediaPipe. So MediaPipe is an open source project which comes under Google AI Edge. It is a suite of libraries for ML and AI. So there are two things which we use in our Android code, which is tasks and models. So tasks are cross-platform APIs and libraries for deploying solutions, and models are our AI models. Then there are two tools which MediaPipe offers to customize our models. The first thing is Model Maker, which helps us train models based on our data, and then there's Studio, which helps us benchmark or visualize or evaluate this model. So let's see a quick demo for the same. There are two different things which are happening here. We are performing gestures, and in real time you will see that the phone is reacting to it. So let's say if someone has difficulty using a mobile because of tremors or whatever reasons, it shows that they can use the mobile just by displaying these gestures, just by using gestures. And then the second one is about generating the screen summaries, which we talk about, and this also happens on device. So let's see the demo. So I am displaying a closed fist gesture, a thumbs up gesture, and an open palm gesture. And then I'm going to settings, and I have clicked summarize, and it gives me a summary of what's on the screen. So now let's see how we implemented this. So we use three tasks: task test, task gen AI, and task vision from MediaPipe for this. And we used two models, which is the Gamma 3 model and the gesture recognizer model, which are again offered by MediaPipe. We have created three services: camera gesture service, global accessibility service, and LLM processing service. So camera gesture service helps basically capture the gesture. The global accessibility service basically performs action. So when I did close fist, it performed action on basis of that. And then there is LLM processing service, which basically creates the summary and then gives it to global accessibility service. So let's understand the precise sequence of events when a gesture is performed or a summary is requested. So when you perform a gesture, our camera gesture service springs into action. It's running as a foreground service, constantly analyzing frames for our camera using MediaPipe's gesture recognizer. This all happens on our device, ensuring low latency and privacy. The moment a gesture like closed fist is detected, the service broadcasts an intent. This intent is then picked up by the global accessibility service. This service is crucial because it performs action or it interacts with the Android system on our behalf. So for example, when I did closed fist, it did a scroll forward action and we saw the content scrolling there. And when I did a thumb up, it went back, and when I displayed open palm, it went to the home screen. Now we can have different gestures implemented or different actions implemented based on these. Now for the summary feature, when we tap the floating button, the global accessibility service collected all the text which was there on the screen, and then it gave it to LLM processing service, which is also running on our device. So this service use Gamma 3 model to generate a concise summary, while again this was on device, keeping the privacy and by keeping the data on device. Depending on the phone's hardware, the speed of generating summary could be fast or slow. And then finally, once the summary was ready, LLM gave it back to the global accessibility service, which then displayed it on the overlay which we saw in the end. So it's end-to-end on-device processing, which ensures privacy and a responsive, sometimes slower experience. So if any one of you is interested in exploring this further, I can share the code base with you for exploring it further. So now let's talk about making AI itself accessible. So we have discussed a lot of time understanding how AI has revolutionized accessibility for people with disabilities. But another crucial dimension is making AI itself accessible. So this starts with very foundation of the training data. So if our so AI models are only as good as our training data. If our training data has biases, our model is going to have biases. If our training data does not have any biases, we will basically see this in the results. So this proactive approach is fundamental to mitigating bias and ensuring that our AI serves everyone equally. The next thing is model interpretability, which is often referred to as explainable AI. Many powerful models which we have today are black boxes. This means they hide the decisions which they made from users, and this becomes especially challenging, significantly challenging for accessibility, and even because understanding AI systems or making how AI is understanding how AI is making a decision is very important, especially in case of high stakes applications. And explainable AI helps to create much more transparent models that can explain their rationale, and then we can analyze strengths and weaknesses of the model based on that. And finally, we should not miss that all the AI tools which we have, the UI UX of them should be WCAG compliant for people to be able to use it. So as I bring my presentation to a close, let's consolidate the core messages I have shared today. So the first key takeaway is the immense potential of AI to enhance accessibility and inclusivity for individuals with disabilities. Secondly, I highlighted the AI technologies that are already assisting individuals with disabilities. The third takeaway is the exciting promise of Google's MediaPipe for future accessibility applications. And finally, a crucial takeaway is the importance of making AI itself more accessible. So what can we do next as engineers to help build a more open and fair digital world? I have three main points for you. Explore Google's MediaPipe and solutions even from other companies, and think about how you can use these solutions to make your apps or your website more smarter and helpful for all users right on the phone. Second, design for all users. So it's important to work closely with people who have different needs, including people with disabilities. Make sure the designs and the data we use in the AI are fair and include everyone. This would help us avoid biases. And finally, use AI for good. So find ways in your own projects where AI can help remove barriers. Think about how AI can make our apps easier to use and better for all people. So I would like to thank GTG Berlin Android team for this opportunity, and thank you all for listening. We are open for questions now.